Hey everybody, thanks for coming back. It's another time for science here. Tuesday scheduled video if you're watching on the day it says. I hope you enjoyed the last one. We're going to get into more talk about thermal energy. I think this might actually be the last science video I make for you, not just this week, but this year. It's amazing. We're already at the end. Again, too bad we're not there together in class to do this stuff and go over all this neat science stuff. But we're making the best we can of it. Tomorrow we got Bill Nye to show you some cool things about heat. Today we're going to talk about a little more easy to get into as far as what we're talking about in the concept of the whole idea about thermal energy being about movement of particles and things that gets a little bit maybe out there as far as grasping the basic understanding. But today we're going to talk about the sources of thermal energy and the ways we can use those kinds of thermal energy as well. Okay, so much more kind of down to earth, basic level kind of stuff. So real quick, just to go through this, it says big thing is with solar radiation. Heat from the sun is where we get most of our thermal energy. Maybe not the thermal energy we necessarily use in our daily lives, but as far as like the total amount of heat, like think about heating up the whole world, is all about solar radiation, which we see down here. That's what we're going to kind of get into and focus in on. We'll get to the other ones too. We'll talk about how we can change solar radiation energy into electrical energy, and that's a form of technology like using solar panels to generate electricity. Since most of the products we use, technology type things, run on electricity, we have to create that electricity or generate that electricity by creating energy transfers from one kind to another. Solar energy is considered a renewable resource, and so solar energy can be really beneficial to use because it doesn't really create pollution like some of the other forms that we'll talk about, which is a sort of a negative side effect of some of the technologies. But for this first one, solar radiation here, it says solar energy, the sun's energy reaches Earth by radiation, like we talked about yesterday. It doesn't touch us directly, it travels through space and gets to us from a distance, and we can feel that heat. Only a tiny fraction of the sun's energy reaches Earth, yet it enables life to exist on our planet. Solar radiation in Earth's atmosphere help keep Earth within the narrow range of temperatures needed for life to survive and thrive. So we have the warmth from the sun, the certain temperatures that allow organisms to survive, like we talked about ecosystems. All kinds of different ecosystems around the world require at least some warmth and heat from the sun, and of course light to help photosynthesis happen. But the solar energy, the solar radiation of heat, warms our planet, and that's definitely a big thing. Okay, I'm going to go down here to the bottom before we get to the combustion fuels, but another main source of natural heat is called geothermal energy. Now this isn't quite as much as the sun's radiation, but geothermal energy, geo means, remember what that means? It means talking about the earth. Geo, like geography, is the study of the earth or mapping. And geothermal energy means heat that comes from the earth. So geothermal energy is thermal energy naturally produced under Earth's surface. Below Earth's cool surface, there are regions so hot that rocks melt. As we get down closer to the core, through the mantle and things, the crust is solid. The further down we go, the hotter it gets, and that's where we have like lava that comes out of volcanoes and things, and that's examples of geothermal heat, geothermal energy. So we can directly observe geothermal energy. Volcanoes, geysers, and hot springs are visible examples of geothermal energy. Here we see an example of a geyser. I don't know how many of you have been to Yellowstone Park, but that is a great area of natural wonder, and it sits on a big hot spring, hot spot. And the Old Faithful geyser is a geyser that builds up from the heat down below and bursts out, there's a lot of heat involved there. One area that in the world that has a pretty prevalent amount of geothermal energy, especially hot springs, is the country of Iceland, which is up here. So between North America, where we are, and Europe is a country called Iceland, which is part of Europe. But it sits right along what's called the Mid-Atlantic Ridge. And this, you can kind of see this line through the Atlantic Ocean. That's actually where the Earth splits apart. And I think you talked about tectonic plates last year in 4th grade as you learned about Earth science. And below there is where it's hot. It's hot under all of the world, but this is basically areas where there's cracks in the surface. So if we go in a little further, we can see this line. And that's where the Earth is actually separated. It tends to be hotter in those areas. It sort of exposes that hot under part of the Earth. And then the country of Iceland is actually a land area that lies along that ridge. And most of this is all underwater under the Atlantic Ocean. But in Iceland, it's an area where they have lots of volcanoes and hot springs and geysers because they're along that ridge where basically those hot parts of the earth are kind of more close to the surface. So there's really some neat, interesting things going on in Iceland. It's far north, as you can see. It's far, like if you look where Canada is, it's the far reaches of Canada as far as how far north it is. So it has cool temperatures, but the hot springs result in quite a bit of heat coming up from inside the earth. And this is just one example I found, just a real quick search. This is a natural hot spring in Iceland. You can see two people just hanging out there, and notice the snow all around. So this is obviously winter and cold, but this water is naturally heated by the geothermal energy down below that heats it basically like a natural hot tub, which is pretty cool. Pretty neat that they can do it. So they can just kind of get in their bathing suits and hang out in there, even though it might be below freezing, obviously very cold outside in the air, but that this water would be heated from the earth below, that geothermal energy. So again, there's a good example of that. Okay. So there again, geothermal energy is another big one. That's a naturally occurring form of thermal energy, not quite as prominent or powerful as the solar energy. Think about the sun shining all day long is a pretty good source of solar heat energy through the radiation. Okay. Now the last one we're going to talk about is this. I'm going to zoom in a little bit. This combustion of fuels. Now this is how a lot of our technologies work. And it says a fuel is a substance that can burn. Combustion occurs when a fuel rapidly combines with oxygen, basically burning fuels. Okay. If you do a campfire or a fire pit in your backyard, or grill with charcoal on the grill, or even just use natural gas for your grill, you're burning that fuel. And that obviously creates heat. It creates the heat that allows us to cook our food or keep our houses warm and things like that. Or sometimes we can turn that, or a lot of times, we can turn this combustion of fuels into electricity. There's a process that involves some other technology, basically allows us to convert burning fuel into electricity, which we can then use for whatever, the computer you're watching me on right now, your phones that we use, pretty much anything that anything you plug into an outlet at home is going to be running on electricity. And usually that electricity is generated by burning fuel, which converts and does some other things, which we'll look at on our next page, to allow us to convert that or transfer that into electricity, which we can then use as energy for our devices and a lot of our technology. But this combustion of fuel, same thing happens in a car when we burn gasoline. We take substances like coal or oils or natural gas, like gasoline we use for cars comes from crude oil. Now, again, this is good because it allows us to do the things we need to do. Again, combustion allows us to heat our homes, to cook our food, to get our cars to move, and get us to go places we got to go, or produce electricity. But the negative side of that is that this creates a lot of pollution. Okay, so as we talk about pollution solutions and being able to use new technology like solar power or geothermal energy, these natural ways of creating better forms of energy and power and using it to create electricity are much more beneficial for the environment. So these are naturally occurring. These are things that we as humans have discovered we can burn, but obviously if you've ever walked through the bus line and you smell those fumes, it doesn't smell good. It's put pollution in the air, and unfortunately that's a big thing going on. So again, we get the benefit of using this energy, but a lot of times we have the risk or the cost or the side effect of when we use the combustion of fuels that creates a lot of pollution. So anyway, something to kind of keep in mind. The more we develop our technologies into the future, the more we'll see hopefully solar radiation. Maybe you yourselves have some solar panels at your house, or some neighbors, people in your neighborhood. You may have seen those solar panels up on the roof, which allows them to use the sun's energy to create electricity or to heat their water, which we'll talk about on the next page. Okay, so again, these are the places we can get thermal energy from. Big one is the sun. The other one is it from inside the earth, and then this combustion of fuels is sort of the man-made version of ways we can create thermal energy. Okay, so again, if you've been doing any kind of backyard campfires or anything lately, it's a good time of year for that, and that's what you're doing when you're burning the wood. You're creating heat, and that's the thermal energy transfer there. Okay, all right, let's go to our next page here. So now we're going to get to the uses of this energy. Okay, so uses of energy, page 310 and 311. Just to talk real quick, to kind of take the same things, this energy from the sun, geothermal energy, and from combustion, just to talk about these real quick. There are a couple neat diagrams here. And we're just going to take a little look at these. So energy from the sun, one way you can use the sun's energy is to heat water for homes and businesses. Water runs through pipes in a solar panel where it's heated by solar radiation. So this is an example. If you've ever seen people that have solar panels like up on their houses or roofs, or maybe if you do, a lot of times that's not used to create electricity for the home, but rather to heat the water in the home. So you can see here a pipe running through. Basically, the water goes up. These get super hot and absorb that heat energy, and then it heats up the water, and then the hot water can go back down. A lot of you, like I have, probably have a hot water heater in your home that runs on natural gas, which heats the water, which, again, that provides us the heat we have. But this is using the natural resource of the sun's light and energy, heat energy, to allow it to do that. So using energy from the sun, that's a big one. There's solar farms now that are used to create electricity from the sun, which prevents us from having to burn coal. Most energy is produced by burning coal, which is, again, good to have the electricity we need, but not so great for the environment. One problem with that right now is that even today it's still pretty expensive for that technology to be produced. So a lot of people in our homes, normal folks, just can't afford that, and it's a big cost associated with, like, dollar cost, to create that technology and put that in place to be able to use. So that's one of the things that, again, you would think, why won't we just do solar panels, because that would make everything great. We wouldn't have pollution. And you're right. But there's the other side of it, is that it does actually cost a lot of money to do that. So hopefully as time goes on, we develop the technology better. We come up with better ways to produce the technology. It'll be less costly and more prevalent and more easily used, and better for the environment in that way if we can use that. So then solar panels can in your homes, most typically on your roof, are used to heat water. Again, water runs through it, heats up in here, goes back down to be able to be used. Okay, let's go up to geothermal energy. Now this is actually pretty neat, and another technology that, again, if we can kind of get more on with this and less on with burning fuel, this would be good. So the hot water coming from inside the earth can go up, like we talked about convection currents. The way that these things get turned into electricity is through this important piece of technology called a turbine, or a turbine, depending how you choose to pronounce it. Basically what happens there is the hot water goes through and spins a generator, and then that can be converted into electricity, and then that electricity is just kind of showing the connection points from one to the other into your home, and we can use it. Okay. Another place where this happens is with hydroelectric power. That's not related to thermal energy, but it is related to using natural resources to create electricity to power homes. So if you've ever been to Hoover Dam, out by the Grand Canyon between Nevada and Arizona, the Hoover Dam is a big hydroelectric power generating station where water flows through a turbine just from the flow of a river, and turns that turbine, and that movement creates electricity. The same thing happens when we burn coal. The heat from the coal goes through and usually creates a steam from another component, and then that creates the turbine spinning and generates our electricity. Now, again, the side effect there, that's the most common way we do it, because it's kind of the easiest form of energy we can get to use that coal to create the electricity. But unfortunately, it is a little costly for the environment in terms of the pollution. So hopefully, as we continue our development as humans, we'll figure out ways to make this more efficient and easier to use, so we can do things like geothermal energy, solar energy, hydroelectric power, to create electricity. But again, geothermal energy in the earth, this is how we can put it to use. The last one, geothermal energy for combustion, or from combustion. These are the engines we use in cars and motorboats and any transportation vehicle that runs on gas uses what's called a combustion engine. It literally creates a spark. There's a thing called a spark plug, and that gas that goes in is literally made to explode or on fire in a very small amount, a very controlled way. But this combustion means like explosion, basically. It's like a tiny controlled explosion, and that's what happens over and over in a vehicle. And as that explosion happens, these are called pistons. And when that explosion happens in one of these areas where you see it, basically it explodes, and that pressure force, that tiny little bit of gasoline is lit on fire and bursts and explodes in energy, and it drives that piston downward. And then another piston does the same thing. When it gets going over and over, it just turns the piston over and over, and that's how that geothermal energy from combustion happens. So this is what happens. Again, that's, again, good that we get the energy, and that heat generated creates the power that allows it to move. But again, burning that fuel can create a lot of problems for the environment. Okay, so that's our main ways there, and that's all I've got for you today. So we've gone through the main sources of where this energy comes from, and then looked at how we can use those sources of energy. Again, let's think about those positive forms down the road. Tomorrow you got Bill Nye. I'm sure I'll be in touch with you guys a little bit more before the end of the year. But that's your last science video, guys, and I am out of time. Have a great day, everybody.